Hey guys, today we're going to look at lesson 10.3, which is titled Parallel Lines and Perpendicular Lines. And we're going to start on page 389 and it's going to run through 392. Specifically in this lesson, we're going to continue to learn about geometric concepts and vocabulary terms needed to classify geometric figures. Specifically, the vocabulary we're going to look at today would be parallel and perpendicular lines. So let's take a look at our learning target. Learning target reads, we're going to identify parallel and perpendicular lines in two-dimensional figures. So parallel, perpendicular, and of course two-dimensional figures would be those flat shapes that just have a length and a width. So let's go ahead and look at page 389. Okay guys, on page 389 with the Unlock the Problem, it reads, you can find models of lines in the world around you. For example, two streets that cross each other model intersecting lines. The metal rails on a train track that never cross model parallel lines. Let's look at our vocabulary terms down here below. Our first one is intersecting lines. And the definition would be lines in a plane. Now this word plane, before we go any further, plane right here doesn't mean like a plane in the sky. A plane figure in regards to geometry would be a flat surface. Kind of think of like a piece of paper. It's flat, but a plane surface kind of goes on and on and on in every direction. So it's a flat surface that goes on and on and on. So let's go back again and read. Intersecting lines are lines in a plane that cross at exactly one point, and intersecting lines form four angles. And so you see we have line HI and line KJ, and when they cross, they meet right there at point X in the middle. And they form four angles, so therefore they are intersecting. How you would read this, you would say line HI intersects line JK at point X. And then how we would write it, we say line HI and line JK intersect at point X. Moving down to parallel lines, they're lines in a plane that are always the same distance apart. And parallel lines never intersect. So you can see here in the draw, we have line DE is parallel to line FG. That's how you would read that. And I want you to take note as well that our distance between these two lines are the same. And they always remain the same distance apart from each other, which is why they will never cross or never intersect or never come to a point together. So that's a really key important part of parallel lines, is that they're always the same distance apart. That's a key feature of parallel lines. Also take note in the word parallel. This is a really good way to remember this. In the word parallel, when you write it, you kind of have the double L right there as a reminder of like a little visual aid of what a parallel line looks like. So kind of think when you see those two double lines or those double L's, that's a good visual aid for parallel lines. It's kind of little, hint for you. Lastly, in our vocabulary terms, we have perpendicular lines. They are lines in a plane that intersect to form four right angles. So really important here that not only are they intersecting, but when they intersect, it's not just any angle they create, but they form four right angles. That's what separates a perpendicular line from an intersecting line, because those two are related in that they do cross and touch and at a point. It's just the angles that are created are different. So you can see here in intersecting lines, we have an obtuse angle, obtuse, acute, and acute. And in a perpendicular line, you have four right angles that are created. So very important there. For our perpendicular lines, you would read it, you would say that Line LM is perpendicular to line NO. And then how you would write it, LM, look at this little perpendicular sign here. That's how you would write perpendicular. And I forgot to mention this. This is how you would write up above the parallel symbol. So you have again, let me highlight that for you. So you have this symbol right here is the perpendicular line symbol. And then up top here, that's the parallel symbol. So those are really important to recognize. Let's shift down a little bit and look at these questions in our map. I tried to make a bigger one for us over here. Okay, so in the try this section, it says, tell how the streets appear to be related. Are they perpendicular? Are they parallel? Or we're gonna write intersecting on the line. Let's look at West 36th Street and Broadway. So I see West 36 right here, and I see Broadway right here. And they do definitely touch each other, so that rules out being parallel. So now they're either going to be perpendicular or they're going to be intersecting. And I'm looking at the angles that are created. And I do see they're kind of at Broadway is a little bit, I guess it depends on which one you're looking at, but they're slanted. The lines are slanted, and therefore they're not creating that nice square corner. So in this case, West 36 and Broadway, they're going to be intersecting lines. So they are intersecting. So they cross, intersecting, but they do not form right angles. Let's look at West 35th Street, and let me erase this. So let's look at West 35th Street and 7th Avenue. So West 35th and 7th is right here. Again, they do cross at a point right here in that intersection. And in this case, I'm going to turn my book a little bit so I can see it, straight up and down, get a better perspective. And when I turn my book a little bit, it does appear that they form a right angle, 4 right angles, in fact. So in this instance, I know they are perpendicular to each other. So and they would also be intersecting. So if you look back at the definition for intersecting, it's just 2 lines crossing, touching at one point, and forming 4 angles. And West 35th and 7th do that. It just goes a step further, and they're perpendicular because when they do touch and cross and form those 4 angles, those are 4 right angles. So they're intersecting and perpendicular. Lastly, we have West 37th and 36th Street. So let's take a look here. So we have West 37th, which is this guy, and West 36th. They do appear to be the same distance apart at all times, and they are not touching, so therefore they are parallel to each other. Let's take a look at our next slide. I thought it would be fun to look at a real-world example of parallel and perpendicular lines. Now take a look and analyze the map that we see here, and can you tell what the map is of or what we're looking at? Take maybe 5 seconds, look at it, look at some of the street names, and then see if you can figure out what the map is of. 4, 3, 2, 1. Well, this is actually a map of downtown Auburndale. So I thought this would be really cool to see parallel and perpendicular lines in real life. I noticed like up over here would be our school is going to be up that way. So, just at a glance for parallel lines, you have Canal, Polk, Rose, Pike, Robinson, Gandy. Those are all going to be parallel to each other. You can see over here you have Armour, Key, James, Sennett, also parallel lines to each other. Let's look at some examples of perpendicular lines. I'm looking at Main Street right here, which is where the park is located, and then you have Bridgers. That actually is, so Main Street is parallel to Bridgers Street. And I'm looking for a couple more examples of parallel or perpendicular lines. What's another good one here? Can you guys find one maybe? Oh, look here, I have Ariana Avenue is perpendicular to Pilakahaka Waka Waka Street Avenue, whatever that is. I don't know how to say it. But anyway, so I thought this was fun and a cute way of, just showing you. Sometimes it's hard to find like real math in the real world and we can't really connect the two. But here is a great example of geometry, parallel perpendicular lines in real life, something that we probably just haven't ever noticed before. Okay, let's go ahead and flip over. Let's look at page 390. Okay guys, let's look on page 390 at the activity section. It's asking us to draw and label ray YX, which is perpendicular. So we're right up here. Let's draw and label ray YX, which is perpendicular to ray YZ, using, and it's intersecting at point Y. So step number 1 says to draw and label ray YX. So if I know they're intersecting at point Y, I know that's going to need to be right here. And of course, when we draw the ray symbol, Y would come first, and then X would be towards the arrow, going towards the arrow. And so then when we draw YZ, again, Y is going to be down here where the point is, and then Z is going to be up here by the arrow. So step 2, again, we're going to connect two rays at point Y, and that's what it would look like here. Off to the side it says, how can you check if two rays are perpendicular to each other? Basically, we want to be looking out for our right angle or our square corner here. So you can use, so I can use a square corner to check if, and I'm just going to do the symbol for a perpendicular. So I can use the square corner to check to see if they are perpendicular. Now let's go ahead and shift up to question 1 and 2. Name the figure that we drew. So when we connected those two rays at the point, we created an angle ZYX, or you could have named it angle XYZ, but we have to have Y in the middle. It's that middle point where the corner is, where they connect together. And can we classify the figure? Can we describe the figure? So angle ZYX is a right angle, and the rays are perpendicular. And if you wanted to be specific, you could say ray YX and ray YZ. Let's move along to our share and show. It says draw and label line QR, which is parallel to line ST. And let's remember that parallel lines are never intersecting. They will never cross. And because they never cross, they have to be the same distance apart from each other. So I'm going to do line segment QR. I apologize there. This should be a line segment, because again, it doesn't have the arrows on the top. So it's line segment QR, which is perpendicular to line segment ST. Now this ST might be longer, right? It might be all the way out here, ST, but they're still parallel to each other. It doesn't matter how long one is to the other. It's just they need to be the same distance apart. So line segment QR is perpendicular, is parallel to line segment ST. Gosh, I was goofing all those terms up there. Sorry about that. Okay, lastly, let's look at number 2 and 3. It says name two sides that appear to be parallel to each other. So let's just, we can pick, I'm going to go top to bottom. So I'm going to say line segment CD is parallel to line segment BF. And then number 3, name two sides that appear to be perpendicular. So I'm going to do line segment CB is perpendicular to line segment, what did I do? CB to BF. And so remember, CB is perpendicular to BF, and they kind of meet right here at that little corner right there of point B. Let's go ahead and flip over to page 391. Okay, question number 4 says name a pair of lines that appear to be perpendicular to each other. So let's look, I want to look for that right angle, because if they're, if I'm choosing lines that don't have a right angle, then they're not perpendicular to each other. So I do see that square corner. It's going to be this guy and this guy. So how I would name them, it would be line FJ is perpendicular to line HG. And you want to put those like little lines up above as well. And then question number 5 says name a pair of lines that appear to be parallel to each other. So the lines that I see parallel to or appear to be, I see line DC and then line FJ. So let's go ahead and get those labeled. So DC appears to be parallel to FJ. We want to put those line symbols up top. And then lastly, I want you to go ahead and pause the video, and I want you to do on your own questions 6 through 13. I want to see what you guys come up with as your examples of drawing the pictures and answering those 2 questions for 12 and 13. So go ahead, pause the video, attempt them on your own, and then click play again, and then I'll go ahead and quickly draw some examples for you for 6 through 13. Okay guys, you should have went ahead and paused and answered 6 through 13, so I'm just going to quickly breeze through here. So it says draw and label a figure described. So we have line segments, so we have line segment RS is going to be parallel to line segment TU, so this would be RS and TU. We have ray KL, and then we have ray KL, and then we also have ray KM. Now I do know they are connected because they share a common point, which is point K. So they need to be touching here. So KL is my first one, and KM is my second one. But you could have had KL this way and KM that way, just so long as you know and can recognize that K is their common point. So either one of those would have been fine. It didn't really say, is it, what kind of angle it created. Number 8, we have line segment CD is going to be perpendicular to line segment DE. So maybe you drew something like this. So we have C, D. Oh, I see. And then we have D, E. This should be erased a little bit. So C, D, and then we have D, E. And this should be a right angle here. Number 9, we have JK. Line JK is perpendicular to LM. Perpendicular, I know I have to form 4 right angles. So we have JK. And then we have line LM. Something like that. And then you have those 4 square corners here. Number 10, we have line ST is intersecting UV. So when I cross them, there should be no right angle. So I'm going to do some sort of diagonal. So ST is going to cross with UV, something along those lines. And then lastly, AB is parallel to, I'm going to go parallel this way, to FG. So AB is parallel to F and G. So it should look something to that effect. And then lastly, we have question 12 and 13. What is the error? You know, I love an error. It says, Dan says that HL, using the figure to the right, says that line HL is parallel, so here's HL, to line IM. Is Dan correct? And explain why. I would definitely say no. If these lines eventually were to keep going, right, they would cross with each other. And the reason why they would cross is because they're not the same distance apart. They eventually get closer and closer and closer. So I would say again, you know, if you extend the lines, they will eventually touch. And they'll eventually touch because they're not the same distance apart at all times. Lastly, number 13, name 2 intersecting line segments that are not perpendicular with each other. Okay, I see we have line segment GK here, and then we also have line segment KL. Those would be 2 line segments that when they meet at that point of K, that the angle created is not a right angle. So again, we have line segment GK, and we also have line segment KL, which would be 2 intersecting line segments. When they cross and meet at that point K, no right angle there. Let's go on to our last page, please. Okay, on this page, I want to do questions 14, 15, 16, and then our test prep along the bottom. I want to look at parallel and perpendicular, but now in another sort of real world example with our floor plans for, it looks like a house here. It says, what geometric term describes the corner of the living room? So we could look at this corner or that corner or this corner. We can definitely say they are right angles. But then using today's new vocabulary, you could also say that they are perpendicular lines. Perpendicular lines. Number 15, name 3 parts of the plan that show line segments. This one at a glance, I mean, you could say any of the walls really. So you could say any walls, doors, like you see this little door right here, and that would be a door. Any walls, doors. I mean, there's at least 3 of those, way more than that. This might be, this skylight right here, this little window. If you zoomed in on that, that would be its own little line segment. And then lastly, number 16, it says name a pair of line segments that appear to be parallel. In this case, you could say opposite sides in any room, I believe, in any of the rooms. Appear to be parallel to each other. And what I mean by that, so you have the living room, the opposite is parallel, or you have the master, those two opposite sides. The dining room and kitchen, those would be opposite and parallel to each other. Let's shift down now to our last problem. If you have time, you can go back and do 17, 18, 19, but I'm trying to wrap this up. It says test prep, which best describes perpendicular lines? Are they lines that never meet? Do they form four right angles? Do they form one acute angle, or do they form one obtuse angle? Go ahead and think about that. I'll give you 5 seconds. Get it bubbled in if you can. 4, 3, 2, and 1. So what's best describing perpendicular lines? We should have picked B, that when they cross each other, they form those four right angles. Okay? Thanks for watching today. Tomorrow you will have the corresponding workbook pages that go along with this. You can always come back and rewatch if you wanted, but I look forward to seeing your submissions for the workbook pages. Bye, guys.